in MHD waves, the first port of call is the equilibrium. We look at 1, equilibrium or equilibria states. If you don't get this, you might not progress. That is the basic. What do? We want to establish a background state. And in most cases, we usually use a subscript 0 to look at this equilibrium. We can look at equilibrium in symmetries, which can also lead us not only in Cartesian coordinates, not in spherical or cylindrical, but in curvilinear vectors. We can look at equilibrium in curvilinear vectors, then convert them. Then, number 2, we need to now move. We had when G is 0 and when G is not 0. They have characteristics. When G is different from 0, we are now looking at stratified medium, atmosphere. Now, the number 2 area is MHD waves, which leads us we should have alpha waves, slow, and the fast magnetoacoustic waves. Now we'll try to see also the effects of gravity that leads us to magnetoacoustic gravity waves. We have reached this level, and there are some problems which I have given to you when we got the involvement of G. Is it not? I gave you one yesterday. I gave you one the other day. Now, next week, when I begin to look at what happens with weak solution, we'll look at what we call weak solution. Look at what we call strong solution. And all those solutions depends on the plasma beta. They depend on plasma beta. 1, if the plasma beta is less than 1, or it is far greater than 1. So these are the media that we're going to take. Here actually is corona. So in corona, are we going to have a weak or a strong, or in photosphere? And then you remember, we also looked at a situation where we said that the beta is defined in terms of x and VA, where we had our fast speed to be equal to square root of cx squared plus VA squared. Is it not? So these are the areas now we will not need to do our computations. All right? Also, the number 3 area that we'll try to look at is we will look into cutoff periods. Those are having to do with frequencies. So we should be able to look at cutoff periods. So we might look at slow, magnetoacoustic waves in solar atmosphere. We can also look at all of them comes to do with cutoff frequency. Like there's a paper which we were trying to, I gave a prof yesterday. Okay, that one tried to look at the exact solution of inhomogeneous. You know, most of the problems, we will look at uniform B fields and the non-uniform B fields. So if we look at these two, so that should be 4. So we will consider inhomogeneous B fields and then see what we can happen with the cutoff frequencies. All right? So these are okay. So, my friends, as I said, we'll start with the equilibrium. See how we can go into waves and then end up in cutoff frequency periods. These are the areas we can develop our problems. All right? These are the areas. I've given you 2 problems. The one you took away yesterday, have we solved that? Did we get it? You attempted. I need to see your attempt. Because if we can get that, we'll not be able to move on and then see where we can. And you remember that our P0 and rho 0 are usually E by H. So they are exponentially decay. We also looked at a situation. With this, you can also have your B field to be also exponentially decay, whatever it is. What I gave you yesterday was to take T as a linear function of Z. Because if you are in one medium, which is isothermal medium, the temperature is assumed to remain constant. It's when you are moving to another layer that it begins to change. So we want to look at a balance where we can assume, instead of assuming the temperature to be exponentially or a constant, let's take it as a linear function and then see the result we get. That's what I gave you that. So if you have gotten that solution that will help us solve that crazy looking Bessel's equation, then you see you have one thing to do there. So that we cannot compare our results by taking it as a constant and see what happens. Okay? Are you going? Okay, now. Okay, we'll see that.
As you're doing, I also did mine.
Okay, no problem.
I'm working on one of my PhD students' work. I'm trying to verify the results.
What are you working on?
We are using different methods of solving flow problems in channels. He brought the works and tried to verify all what he has done. That's
Okay.
what I'm doing. It's
No
taking- it's
problem.
taking me time to do
Yes.
so.
Okay, Ngwanu.
Well done, sir.
Okay.
Well done, sir. You
Okay.
did very well.
Well, what do we do now? Let's see the ones we can carry and put in our pockets.
Yes. I understand, sir.
So we will all this. So you can see what is here. We have almost 4, 5, 6 papers to go on. I don't know the people who work in the area, but I would work with Prof and Doc on that problem I showed you yesterday. So we initiate that one and see the one they can look at if we are going to take the temperature to be linear instead of sinusoidal or exponential. I know where your mind is. So I'll give you another problem which you will solve. Then by Monday we kickstart. I think that's the best thing we can do. I don't know whether they give you people photocopy. Can they give us photocopy? There's something I was looking at. There was something I was looking at this morning. Is it here? Okay. See, I want them to read this. Come now, you are with us. I want them to read this introduction. You see here.